Okay, in this mini lesson we look at inverse trig functions. Now, the first function we're going to look at is y equals the arcsin of x. Now, you might see it in your textbook written with this minus 1. I don't prefer to use that, but that can be easily misconceived because that's also where we put our exponents at. And so this symbol here does not mean sine to the minus first power. It doesn't mean 1 over sine. It doesn't mean cosecant. It means the inverse of sine. So to avoid that, I just put the word arc in front. They mean the same thing. And so you'll see me using arc, although the textbook will use this inverse symbol here in the spot that we normally have an exponent. And so how does this work? So we already talked about how inverse functions will switch the domain and range. Your inputs become your outputs become your inputs. But you can't always do that. What you need is for your function to be 1 to 1. Y equals sine x is not a 1-to-1 function. If you look at the graph of it, it definitely fails the horizontal line test. You'll have more than one x for each y, and we can't have that. So what we must do then is restrict the domain. We can't have the domain be what we can't have the domain of sine be the entire domain of minus infinity to infinity. We have to restrict it so that we can have a part of the domain that will actually pass the horizontal line test. And in practice, we could do any part, but in practice what we use is minus pi over 2 to pi over 2. There, just for that part where it's bolded at here, we actually pass the horizontal line test. Every y has one and only one input that goes with it, x. And so that's our restricted domain. And then the output, the range, would be all values y from minus 1 to 1. So for the arcsin, for the inverse, these will now switch. Not that we have to spend too much time talking about the graph of arcsin. I want you to spend more time with the application of being able to evaluate the function, but just so you can connect it to what we talked about before for inverse functions, we're doing it now here. So this is not something that you have to memorize, but x's become y's, y become x's, and now my x range, which was minus pi, my x domain, which is minus pi over 2 to pi over 2, become my y range, minus pi over 2 to pi over 2. My y range becomes my x domain now. And this is my arcsin function. This is the graph of arcsin with this, by convention, chosen restricted domain of sine. And so we'll never study this in detail. You don't have to memorize this, but what we want to spend most of our time is being able to evaluate the function, not by looking at the graph, but just the concept of what an arcsin is. And so there's a blow up of that graph there, and we don't have the extended parts out here. And so so the domain is minus 1 to 1, and the range is minus pi over 2 to pi over 2. So what comes into the function is a result of plugging that angle into sine. What comes out of the function is the angle. Before, the input was, for sine of x, the input is the x, the angle, and the output is the result. So now we flip that. The input is the result, and the output is the angle. Okay? If you compose these two functions one after the other, they're inverses of each other, and by definition, then you're supposed to get back out x. These two operations, if you think about it, cancel each other out. The arcsin of the sine and reverse the sine of the arcsin. And we actually will end up using that to try to figure out what the later on to try to figure out what the derivative of this function is. We'll end up using this fact here. This is more like a definition of what it means to be an inverse function anyway. The composition of a function with this inverse will always result in x in any order. Okay. So now let's look at our restricted. So we're going to focus our attention on unit circle because we're going to basically be reading the unit circle backwards. So we're looking for the angles that give you a particular y value of, the y value on the unit circle is the sine. And so if I ask you the arcsin of -1/2, you'll just have the unit circle, since you don't have a calculator. You'll be looking for where is the y value at -1/2. The reason why we're only looking at this right-hand side, because remember, the range, the answers, the outputs must be angles between minus pi over 2 and pi over 2. We can't call these guys the positive versions of these angles. We must give an answer between minus pi over 2 and pi over 2. So when I look and see the y value being -1/2 for this angle here, negative pi over 6, that is my output. That's my answer to the question. Arcsin of -1. I go and look for the y value to be negative 1, and my response then would be the angle that gives that negative pi over 2. And we have the definition. It's out of order here, my animation, sorry. Where's the y value? Root 3 over 2, it's for pi over 3. So we can answer the question just by reading the unit circle in reverse.